When we look up at the night sky, we are literally only seeing a tiny fraction of the whole story. Welcome to This Explainer. Today, we're diving straight into the hidden architecture of the cosmos, specifically the galactic halo. We're going to explore the massive, entirely invisible structure that actually defines a galaxy's true shape and size. For decades, our understanding of what makes up a galaxy has been totally dominated by the stuff we can see, right? The luminous stars, the glowing gas, those beautiful bright dust lanes you see in breathtaking telescope images. But astrophysics has increasingly shifted its focus to the dark, to the unseen, to the massive gravitational scaffolding that actually holds all these magnificent structures together. This is where the real mechanics of the universe operate, out in these vast, hidden realms that completely dwarf the starry disks we're so used to looking at. Okay, let's dive right into this. Where does a galaxy actually end? It sounds like a pretty simple question, but the answer totally upends our standard models of the cosmos. We usually default to picturing a galaxy as this definitively bound, flat disk of stars, right? Like a tightly contained system with clear physical limits. But if we want to grasp the actual mechanics of the universe, we have to look way beyond that visible light. We've got to challenge this intuitive assumption that light equals boundary. If we were to zoom out, and I mean way out, past the spiral arms and the dense galactic core, the whole definition of a boundary just starts to break down. The gravitational influence of a galaxy extends radically further than its luminous matter. So to really understand a galaxy's true footprint, we have to map out the invisible mass that dictates the motion of literally everything inside it. Historically, the baseline scientific consensus has described the galactic halo as nearly spherical. So scrub that image of a flat disk from your mind for a second. Instead, I want you to imagine a massive, totally invisible globe fully encompassing it. Think of it like a giant, isotropic sphere just suspended out there in deep space. For a really long time, visualizing this almost perfectly round, unseen shape was the go-to paradigm for astrophysicists. It was how we understood the hidden structural integrity that holds stellar disks together. And honestly, it made perfect sense. This spherical model gave us an elegant, mathematically convenient way to explain rotation curves and how galaxies are gravitationally bound. It was the standard scaffolding, this immense, dark bubble acting as the foundational container for all the chaotic, swirling matter trapped inside. Now, what's really interesting about this is that the reality is proving to be so much more complex than just a simple, uniform sphere. Recent studies and incredibly advanced mapping techniques are showing us a stark contrast to that classical model. Rather than a perfectly round bubble, the halo can actually be slightly flattened. Picture an oblate spheroid that's being completely distorted by vast rotational forces and the complicated gravitational dance of surrounding satellite galaxies. And honestly, even more fascinating than that is the evidence suggesting the halo might actually be fractured into multiple distinct subcomponents. So instead of a single smooth distribution of matter, we're looking at an intricate, textured architecture with totally separate, dynamically distinct regions. We're actually seeing the remnants of ancient galactic collisions, invisible streams of matter, and stellar currents creating this deeply fragmented, complex environment. It's a complete game changer that fundamentally shifts how we model the evolution and structural integrity of the cosmos. So shifting our perspective outward to the extreme edges of these structures, the source material points out something that is just deeply counterintuitive about galactic mechanics. It states, quote, "It does not have a hard boundary." Just think about that for a second. In our day-to-day terrestrial experience, physics is totally defined by edges and surfaces, right? A planet has a crust. An atmosphere eventually gives way to a vacuum. But a galaxy completely defies this neatly packaged geometry. There is no definitive surface. There's no cosmic wall or explicit line in the sand separating the galaxy from the vast intergalactic medium. It's an open, continuously interacting system. And this lack of a hard boundary means a galaxy is in constant communion with the space around it, quietly absorbing material and subtly extending its gravitational reach way out into the supposedly empty void. So the crucial point here is how this tapering actually works in practice. The density of the galactic halos simply decreases as you move outward, eventually blending completely seamlessly into the surrounding space. It's exactly like a thick fog dispersing into the morning air. The concentration of dark matter, the sparse stars, and that tenuous gas just grows thinner and thinner the further you travel from the galactic core. There's no sudden drop-off. Instead, it's this smooth, asymptotic decline in density. At a certain point, the local gravitational pull of the galaxy literally becomes indistinguishable from the background density of the universe itself. The matter of the halo and the sparse particles of the intergalactic void just merge together completely. It makes it fundamentally impossible to draw a definitive line where the galaxy actually ends and the rest of the universe begins. Let's bring this abstract concept home to our own cosmic neighborhood for a minute. Right here in the Milky Way, this invisible halo extends so far beyond the main visible disk. That bright, beautiful spiral of hundreds of billions of stars that we call home, the exact structure we map out in all our textbooks, is completely dwarfed by its unseen counterpart. We actually exist deep within the core of a much larger, much darker entity. The visible Milky Way is essentially just the glowing nucleus of a massive unseen ecosystem. And understanding this completely reframes our entire perspective of our place in the universe. We aren't just riding on the edge of a cosmic pinwheel, we are submerged deep inside an immense, diffuse ocean of matter that stretches out in literally every conceivable direction. Tens of thousands of light years. That is the awe-inspiring scale we're talking about here. Current estimates push the Milky Way's halo vast distances out into the darkness, stretching tens of thousands of light years beyond the stars we can actually observe. I mean, just try to conceptualize that sheer volume. Light itself, which is literally the fastest phenomenon in the universe, takes tens of millennia just to cross this unseen territory. This ghostly shell contains the vast majority of our galaxy's mass. It exerts the primary gravitational influence over everything within it, dictating the orbital speeds of our own solar system and even the ultimate fate of our local galactic group. So why does understanding this unseen architecture actually matter? Because it fundamentally changes our entire view of the night sky. We aren't neatly contained at all. We're floating inside a massive, fading sphere of influence that seamlessly connects us to the broader universe. Our galaxy is essentially breathing with the cosmos, exchanging matter and energy without any rigid borders. Which brings us to this. If our halo simply blends into the surrounding space, smoothly transitioning right into the void, what exactly is waiting in the dark beyond our visible disk? What unseen structures and currents lie out there in that expansive, fading boundary? It's a profound question, and one that should definitely keep you looking up, reminding us that the absolute most significant parts of our universe are very often the ones we cannot even see. Thanks so much for joining me on this explainer, and I'll catch you on the next one.